In this video, we look at solving some permutations related problems. So this question here is about a series of books on a bookshelf. There are 31 books. 2 of them are pink. We're going to assume that the books are put on the shelf properly, so the spines are facing the right way, they're right side up, and so on. And the question here is asking or saying that the shelf only has 4 books, and a pink book has to be on each end. So the question is asking how many different ways can we do this. So I'm going to start by laying out at least slots or locations for our 4 books. Here are our 4 books. We're saying that on either end we need a pink book. I'm going to label these pink book 1 and pink book 2. And then we need to look at how many ways we can arrange the remaining books. So when we do this, we need to consider, well, how many books are left. We took the 2 pink books out. There were 31 books in total. Now there are only 29 books. So there are 29 books that could go in here and 28 books that could go here. So if we look here, we want to have a book at the front and the first column, the 29 books here, 28 books. We want to have all of these things happening. So we want to look at how many ways this can happen. Well, another way to write this is a permutation of 29 objects where we're taking 2. And if we do that on the calculator, we should get 812. Now, if you've forgotten how to do that or what it means to have this permutation, don't forget that this permutation of 29 items where we're taking 2 can be written as 29 factorial over 29 minus 2 factorial, which is the same as, I don't know if I'll have room for this, but 29 factorial over 27 factorial. And 29 factorial is 29 times 28 times 27 factorial. We get a 27 factorial in both the numerator and the denominator. So we can divide that out here and here. So we end up with 29 times 28. So same sort of rationale for just doing this little bit right here. Now the trouble is that this doesn't count all of the arrangements. This only counts the arrangements where P1 is at the front and P2 is at the back. So we need to make some adjustments here, and that adjustment is really just multiplying by 2, because there are 2 ways to arrange the pink books. There's this way, or there's this way right here. In fact, what we really want to do is figure out how many arrangements could we make of the 2 pink books. There are 2 books and 2 locations. There are 2 factorial ways to arrange the pink books. So the total number of arrangements then is equal to 2 factorial times P29 2, which works out to 2 times 8, 12, which is the same as 1,624. So there are 1,624 different ways that we can arrange 4 books with the pink one at the on either end. All right, let's continue on here and look at the other questions. So part B says the shelf will only have 8 books and the pink books must be together. So what we're going to do here is, here are the 8 books, the 8 slots. We're going to put the 2 pink books together and we're going to treat them as one unit. So we're going to move them around together. I'll just put them here at the end and we'll call this a single unit. So pink 1 and pink 2 going here. If we're going to treat those books as one, we now only have 7 slots. 1, 2, 3, 4, 2, 3, 4, 5, 6, and this is the 7th slot. So the number of ways that we can do that becomes, well, let me back up here. We have 31 books. We've used 2 of them, so there are 29 books here, 28 for here, and so on. And that's the same as a permutation of 29 items where we're taking 7 of them. Not 8, because we're treating the 2 pink books as one. We want them to go together. So that will give us the number of arrangements where we can have this setup here, a whole bunch of different books here, with a P1 and a P2 together. Not necessarily at the end, I've just kind of put them at the end, but they don't necessarily have to be at the end. The trouble here, similar question to the last one, is that we have multiple ways to arrange this. So for every one of these arrangements here, we can switch P1 and P2 around. So we need to multiply by the number of ways that we can arrange those books, which is 2 factorial ways to arrange that, or in this case, just 2. So then we can go to our calculators and plug that into the calculator and get an answer. And when I plug that into the calculator, I get approximately 1.6 times 10 to the 10. So there are 1.6 times 10 to the 10 ways to have 8 books on the shelf with the 2 pink books together. Not the last question, sorry, the next question here says, how many ways can we arrange all of the books on the shelves if there are no restrictions? So, well, there are 31 books in total, which means there are 31 slots. 31 for the first, I won't do all 31, but 31 for the first, 30 for the next, and so on until we get to the last book, which is just the same as 31 factorial. So again, 31 factorial is a very large number. We get 5.3 times 10 to the 32. So there are 5.3 times 10 to the 32 ways to arrange the books with no restrictions. Now this last question I like because it requires a little bit of thought. I might need a little more space here in order to do this question. So we'll just kind of get, let's see what we can do. So it says that all books are on the shelf. All books on the shelf, but the pink books must not be together. So a little bit different from the previous question. So we're still going to put all of the books on the shelf, but the 2 pink books will not be together. And there's a little bit of a hint here. We know how many ways the books can be arranged with no restrictions. We know how many ways they can be arranged with the pink books together. Now we just did a smaller sample of this problem up here, but we're going to use that. So this is sometimes called the indirect method. It's called the indirect method because we're not going about it head on. We're kind of taking a roundabout way, and that roundabout way is to say, hey, let's look at the total here. Total number of arrangements minus the number with the pink books together. Well, we know that the total number of ways to arrange the books is 31 factorial. 31 factorial. And we know, similar to the work that we did up here, that the number of ways that the pink books are together. Now here we were talking about 7, only putting 7 books on the shelf. We're actually going to put all of the books on the shelf. So there are 2 books that are pink. We treat them as a single book, move them together, which means that there are 30 different spots that we're trying to fill. So there are 30 factorial ways to do that. But again, for each order, each one of those, we can change the order of the 2 pink books. So we multiply by the number of ways that the pink books would be together. So again, we can go to the calculator and see what we end up with here. And when we plug this into the calculator, if I've plugged it in correctly, we get 7.7 times 10 to the 33. So that tells us how many different ways we can arrange the books with the pink books not being together. So it's really important that you read the question carefully. You know, there's one word here, if you don't read very carefully, that one word could throw you off entirely. So just a reminder, we took the total number of arrangements that we could make, we subtracted the number of arrangements that the pink books were together, so we treated them as one book, and then we realized that for every one of those books, so every one of those arrangements, pardon me, we can switch the order of the 2 pink books. All right, moving on to the next question. So the question here is, how many ways can you arrange the books on the shelf if you only want 4 books? Maybe this seems a little bit easy now, but there were 31 books in total. We want 4 of them. And again, don't forget that factorial notation. Really, this just means 31 factorial over 31 minus 4 factorial. Or you can go right to your calculator, plug that into your calculator. And if I'm not mistaken here, we're going to get 755,160. Similarly, for 7 books, we're looking for P31.7. And I get approximately 1.3 times 10 to the 10. And the last one here, 13 books, P31.13. And when I do that, I get 1.28, call that 1.3. So it's approximate 1.3 times 10 to the 18. So that's how we can use some of the knowledge that we have about permutations to solve some more sort of challenging problems. Hope you found that useful.